Okay, this is more work from section 4.4. This is number 27, and my notes are kind of neat on this, so I'm just going to use these notes rather than rewrite this in ink. I hope you can read it. If there's any problems, just email me. And then what we have is we have a tour service. This is number 27. Read this in your book. You operate a tour service that offers the following rates: $200 per person. If 50 people, that's the minimum number to book the tour, go on the tour. For each additional person, up to a maximum of 80 people total, the rate per person is reduced by $2. If it costs $6,000, that's a fixed price, plus $32 per person to conduct the tour. How many people does it take to maximize your profit? Okay, so profit will again equal revenue minus cost. How much money I bring in, how much it costs me to run the tour. Now let's let X equal the number of tickets sold or the number of people that go on the tour. That's going to be a minimum of 50 to start it, and it goes up to 80 because that was the maximum number. So X is between 50 and 80. All right. So my profit, my revenue will be the ticket price. That's how much I sell each ticket for times the number of tickets. In other words, if a ticket is $1,000 and I sell 2 of them, my revenue is $2,000. If it's $1,000 and I sell 3 of them, 3 times 1,000 is 3,000. That's my revenue. Okay, now what's my cost? Well, they gave you the cost. The cost is actually $6,000 to get everything going. That's my basic fixed cost plus $32 per person or per ticket. So if I have 2 tickets, it would be $6,000 plus $64. If I had three tickets or 3 people, it'd be $6,000 plus 3 times 36 or $96. So $6,096. So this is how we kind of work that out. Okay, now here's the tricky part. Okay, my ticket price. What will my ticket price be? Well, it varies depending on how many people we have. So they say it is $200 per person. Okay, for each additional person, we reduce the rate by $2. So the number of tickets. So if it was just $2, by the number of tickets, that'd be one thing. But we have this little factor we have to figure out. So this is you have to kind of work this out. So, in other words, if I have 50 people going, okay, my ticket price is $200. Okay? For each additional person past 50. So if I have 51 people, I'm going to take away $2. If I have 52 people, I'm going to take away $3. If I have 53 people, right, I've got 3 people over 50, so I take away 2 times 3 or $6 per ticket. So the ticket would be like $194, right? So you have to put this little factor in here, and it's going to be between 50 and X, and if you tried either way, you'll find out that if X is 50, it's going to work. If X is 51, it's going to work. If X is 52, 52 minus 50 is 2. That's the number of people past 50 I have. So you kind of work it out, and you might just try either 50 or X, and in the front, either 50 minus X or X minus 50, and it works out. This is the number of tickets. If the number of tickets is over 50, that difference over 50 times 2 is how much I reduce that. So it's a little hard to figure out, but you can do that. Okay? So this will determine my ticket price. $200 minus 2 times however many I'm over 50. And this little factor tells you how many you're over 50. If I've got 51, I'm 1 over 50. 52, 2 over 50. 53, 3 over 50. 54, 4 over 50, because 54 minus 50 is 4. So that's how you kind of think that out. Now that's my ticket price, but how much will my revenue be? Well, I have to multiply that times the number of tickets I sell. So if it was 50 tickets, it would be 50 minus 50 is 0, so I would subtract nothing, so it would be 200 times 50, which would be $10,000. Okay? And my cost would be 6,000 plus 32 times 50. Okay? So you can figure that out. Okay. Now I'm going to simplify this because this is a big old mess here. There's all kinds of x's and numbers, so I'll multiply this out. First of all, I simplified side here, negative 2x plus 100. And then I can combine this, it'd be 300 minus 2x, and I multiply that times 100 at the same time. So I got 300 plus 100x, 200x plus 100x is 300x minus 2x squared. And then over here I had negative 6,000 and negative 32x. Then I can combine my x's, so I've got negative 2x squared, 300 minus 32 is 268x minus 6,000. So finally I've got my profit function all simplified. But if I wrote this down, you'd have no idea how I got it. This is how you get it. Okay? So think about this one. This is a good one if you can really kind of piece this all together. Okay? And we have covered problems very similar to this in our pre-calculus book. So we did some of these last year if you had me for pre-calculus. Or Miss Margalla. We used that in our book. Okay? Very similar problem. Except we just had to set up the function. Okay? Now this is a parabola, and we did algebraically. It's a parabola. It's shaped like an N, so we'll have a maximum. And all we did was we found the vertex last year, so we used algebraic methods to solve this. So this is one of those kind of problems that you can use algebraically, and you can always check it. You know, use minus b over 2a to find the x, and et cetera, and you can find the you could find your number that way. But we're going to use calculus, so we'll take the derivative. That's going to be negative 4x plus 68. That's just a nice straight line. That's what's going to happen on the ones that we can use algebraically. It's not going to be undefined because it's a straight line. So we just set it equal to 0, and x equals 67. So whether you use minus b over 2a to find the x value, which you'd get the same thing, or you do it like this. This is a calculus way. You're going to get x equals 67. Now we're going to check to see that is that a maximum or a minimum. Now again, we know that if we graph this, this is going to be a... If we graph this, this is going to be an n, so it is going to be a maximum, but we can check it over here using our calculus method by using our first derivative test. And we tried 51 and 70. I got negative positive, so I did have a relative maximum. Now there's two ways to do this, and I kind of emphasize that also. In other words, it has a relative maximum because p prime changes from positive to negative there at 67. Or we could have taken a look at the second derivative. If you take the second derivative of what is this, that's negative 4, which is always concave down, which means because it's negative, it's always concave down, so that would have to be a maximum also. So you could have used the second derivative test also. So you also get an absolute maximum. So how many people does it take to maximize your profit? It would be 67 people. So that would be your solution. And this was just using the second derivative test as an alternate. So 67 people to maximize profit. There you go. Okay. So I hope you can follow that. I hope it helps.